What's good? It's You'll Be Blessed here. Making it clear, making it plain, opening up the heavens for my teaching is like spring rain. And today we're going to tackle writing the chemical names for ionic compounds that include those transition metals. Because transition metals can have multiple charges, thus multiple names, we must start with the charge of the anion. So let's look at oxygen, or oxide. By looking at a periodic table or a list of your choice, you can verify that oxygen has a -2 charge. The next thing we want to do is get the total amount of negative charge by multiplying the subscript of oxide by its charge. Since we know that ionic compounds must be neutral, that means the total positive charge must be equal but opposite, a +4. From here, we want to verify the total charge of the platinum ion. We do that by imagining a subscript 1 behind platinum. Then we take the total positive charge and divide it by the cation's subscript. 4 divided by 1 is 4. Therefore, the platinum ion requires a Roman numeral 4 in its name, platinum 4 oxide. Let's look to another example of naming ionic compounds. Cu3N. Notice that there's a transition metal in there. We always want to begin with the charge of the anion, which is nitride. You can use a periodic table of your choice or a list of your choice to determine that the nitride ion has a -3 charge. Here's our -3 charge, and next we want to multiply the number of nitrogen ions, which is 1, times the charge of the nitride ion, which is 1 times -3 is 3. Since we know that the ionic compound must be completely neutral, that means the total number of cations positively charged must be equal but opposite, which is a +3. From here, we want to verify the charge that copper can have. We do that by taking the total positive charge and dividing it by the subscript of the cation, which is 3. Therefore, 3 divided by 3 is 1. The copper ion must be a copper 1 ion, and thus copper 1 nitride is the name of Cu3N. Let's look to this really simple example of writing chemical names for ionic compounds. Notice that it is TiS. We first need to verify the charge of the anion, which is sulfide. We can verify this by using a periodic table of your choice or using an ion list of your choice. The charge of sulfide is -2. Next, we want to take the number of sulfide ions and multiply it times the anion charge. In this case, we have 1 sulfide ion, so 1 times a -2 is a -2. Since this is an ionic compound, that means the total charge of this ionic compound must be equal to 0. Therefore, the cationic charge has to be equal but opposite, which is 2+. Next, we verify the charge of the titanium ion by taking the total positive charge and dividing it by the subscript of the cation, which is 1. 2 divided by 1 is +2. Therefore, the titanium ion must have a +2 charge, and thus when we name it, we use the Roman numeral 2, titanium 2 sulfide. Thanks for tuning in to You'll Be Blessed STEM Education. I hope you were blessed by the contents of this video, and if you were, be sure to like, comment, and subscribe to this channel for more teachings that feel like a refreshing spring rain.